Today, we're talking about something that's basically the internet's giant, infinitely scalable filing cabinet. It's called object storage, and it's the system that holds pretty much everything, from your vacation photos to the entire backbone of massive web applications. So think about it for a sec. On your own computer, you have folders inside of other folders, right? And that works just fine for a few thousand files. But how on earth does a service like Netflix or Dropbox manage exabytes of data? I'll give you a hint. They are definitely not using folders. They're using something fundamentally different and a whole lot smarter. All right, so here's our roadmap. First, we're going to go beyond folders to really get our heads around this new way of thinking. Then we'll dig into what actually makes an object so special. After that, we'll check out the industry standard, Amazon S3, look at some other players in the game, and then wrap it all up by talking about what this means for the future of, well, all of our data.
Okay, first things first, we need to kind of rewire our brains. We have to move away from that tidy, rigid world of folders and files and step into this massive, wide-open universe of data.
This really shows the core difference. On the left, that's your computer, a strict hierarchy. You need the exact path, the exact address to find anything. But on the right, that's the cloud's way. It's just one giant flat space. You know, it's kind of like a coat check at a huge event. You hand over your data, they give you a unique ticket number, and that's it. You don't know or care what rack it's on, you just need that ticket to get your coat back instantly. So, this is the really cool part. What's the big difference between a simple file and a powerful object? Well, in one word, intelligence. You see, in old-school storage, your data is just, well, a bucket of bits. That's it. To the system, it's just a long, meaningless string of ones and zeros. The system has no clue if it's a picture, a song, or a secret document. But with object storage, that data actually takes form. It's not just a blob of bits anymore. It becomes an object that the system itself can understand. The storage system has knowledge about the data it's holding, which unlocks all sorts of powerful new things you can do with it. So, how does this happen? How does dumb data get smart? Well, here's the secret sauce. It's a simple formula. You take your original file, the data itself, and you wrap it in this rich, descriptive information called metadata. And boom, that combination, that's a smart object. So what is metadata? It's just data about your data. Think of it in two flavors. You've got your system metadata, stuff that's usually created automatically, like when the file was made, but then you have custom metadata. And this is where the magic really happens. You can add your own descriptive tags like category travel or subject lighthouse. This makes your data searchable and organizable in ways you could only dream of with a normal file system. And how do we talk to these objects? Well, we don't browse folders. Instead, we use the simple universal language of the internet, a REST API. It's super straightforward. You use a get command to ask for an object, put to store a new one, and delete to get rid of it. That's it. It's an incredibly simple and scalable way to manage just about anything. Okay, enough with the theory. To make this all feel real, let's look at the system that basically wrote the rulebook for object storage at a global scale. Amazon's Simple Storage Service, or S3. In S3, everything is built from three simple things. First, you have buckets. Just think of them as big containers for a project. Inside those buckets, you put your objects, your actual files, and these things can be massive, up to 5 terabytes each. And finally, to find a specific object inside a bucket, you just use its key, which is really just its unique name. And here's what it looks like in practice. This URL is a perfect example. See John Doe? That's the bucket name. And resume doc? That's the key. That one simple web address can pinpoint a single file among trillions from anywhere on Earth. It's just so elegant and ridiculously powerful. Now, while S3 might be the 800-pound gorilla, it's not the only game in town. The core ideas of object storage are so good that lots of others have adopted and adapted them. A really big open-source alternative is OpenStack Swift. Now, the architecture on the left looks complicated, sure, but check out its data model on the right. Does that look familiar? The concepts are almost identical to S3. Instead of buckets, Swift calls them containers, but it's the same idea. An account holds containers, and containers hold objects. It's just another flavor of the same powerful, flat structure approach. Now, this whole flexible, object-based way of thinking is so revolutionary that it didn't just stop with file storage. These same core ideas, treating data as self-contained units in a flat space, also became the foundation for a whole new type of database called NoSQL, and Amazon's DynamoDB is a perfect example. The thing that makes DynamoDB so amazing is that it's schemaless. Just look at these examples. In a normal database, every single person would need to have the same fields, like name, address, and phone. But here, each item can be totally different. Fred just has a phone number, Mary has a full address, and Howard, he has an address and a favorite color. This incredible flexibility comes straight from that object storage mindset. Every piece of data defines its own rules.
Okay, so let's zoom out and bring this all home. Why is this big shift from folders to objects so incredibly important?
At the end of the day, it's simple. Object storage is the engine that powers the modern internet. Without its ability to scale to unbelievable sizes, to keep our data safe and durable, and to make it all intelligent with metadata, the massive data-hungry apps we rely on every single day just wouldn't be possible.
And that kind of leaves us with one last really exciting question. We've gone from treating data as a dumb bucket of bits to data that actually knows things about itself. If our data is already this smart, just imagine the questions we'll be able to ask it tomorrow. What new discoveries are just waiting to be found in this world of smart objects?